Lesson 20 demo. Today we discover formulas for the derivatives of trig functions and use them with other derivative rules to solve optimization problems. Below is the graph of y equals sine x. We don't yet have a way to differentiate this function, but let's try to sketch the graph of its derivative on the axes below. So actually a few classes ago I did share with you the derivative of sine of x, but we're going to pretend that we didn't know that because that was sort of unofficial, informal at that moment, just to give us more practice with the chain rule. So we know that if we're going to graph functions on the derivative, then we are plotting points of the form x coordinate and then slope of the tangent line at that x coordinate. So how about we pick maybe 5 points on this particular graph, and then we will draw a tangent line, little tangent line at each of those 5 points. And then very quickly estimate the slopes of those tangent lines. So I don't know, this first slope maybe is 1. Second slope for sure is 0 if I pick the point at the top. Maybe this is a -1 here, that's another 0, and I guess this has to be the same as the first tangent line, which we said was 1. And so if I'm plotting points again in purple up there of the form x comma slope, so then this first point, the far left point right here, the x is equal to 0 and the slope is 1. So I'm plotting the point 0 comma 1. For the next one, the x is this guy, which is pi over 2, and then the slope is 0. So pi over 2 comma 0, right there. And then the next one is at pi, and then the slope is -1, so that would be down here. And the 3 pi over 2 comma 0 is here, and then 2 pi 1 is back up here. And then we're going to connect these with some smooth curve. And that is our rough sketch for the graph of y prime. And so based on our sketch, let's guess the derivative of y equals sine of x. Well, my goodness, this sure looks an awful lot like the cosine graph. And it is surprising, but it is true. The derivative of sine of x is miraculously cosine of x. So then we can use the chain rule to do the derivative of sine of stuff. Sine of stuff becomes cosine of the stuff, but then the chain rule says multiply by the derivative of the stuff. Okay, let's try number 2. This is the graph of cosine, and we're going to try to sketch the graph of its derivative. So we'll do this one a little bit quicker. Tangent lines at the same 5 points. And then we'll estimate slopes. Maybe that's a 0, a -1, a 0, a 1, and a 0. And then we'll plot purple points for the derivative graph. So the first one, x is 0 and the slope is 0, so that's the origin. The next one, x is pi over 2 and the slope is -1, so that would be down here. Next one is x equals pi and the slope is 0, so here. 3 pi over 2, a slope of 1. And then finally 2 pi, a slope of 0. And then we sketch the graph. Okay, so the derivative of sine we saw up above, or at least we conjectured up above that the derivative of sine is cosine. Is the derivative of cosine sine? Is that purple thing the graph of sine of x? And the answer is no, right? Sine starts good, starts in the middle, but sine is supposed to go up, right? Starting in the middle and going up. And this one does not. And so maybe, just maybe, the derivative of cosine isn't sine, but rather is negative sine. And in fact, surprisingly, it is. Therefore, with the chain rule, cosine of stuff becomes negative sine of that stuff times the derivative of the stuff. Okay, so we're not going to prove our 2 new derivative rules, the ones for sine and cosine, but they're true nevertheless. Hopefully the graphs gave us some compelling evidence that maybe, just maybe, this miracle happens. But there are 6 trig functions, and each of them has a derivative. So the first 2 are up here. We've already seen them. Sine is cosine, cosine is negative sine. The other 4, actually, you can prove really easily as long as you know the first 2. And so I think in the activity, you're actually going to prove one of these things. But for right now, we're just going to use them, or I'll just tell you what they are. Derivative of tangent is secant squared. Remember that squared really means you're taking the secant function, the whole thing, and you're squaring it. And the derivative of cotan, we're just going to look over here, is negative cosecant squared. So there is some symmetry here, right? Tan was secant squared, cotan was negative cosecant squared. Derivative of secant of x is secant of x times tangent of x. The derivative of cosecant is negative cosecant x times cotangent x. And again, there is symmetry there. And in fact, I've written these columns in a very particular way. All of the trig functions that start with the letter C have negative derivatives. The ones that don't start with the letter C have positive derivatives. And then if you line things up just this way in terms of rows, then the functions that are written become their co-functions. So secant becomes cosecant. Secant becomes cosecant. Tangent becomes cotangent. Cosine, its co-function is sine. So if you memorize the one column and you understand the relationship between the columns, then the second column pretty much comes for free. So memorize these 6 derivatives tonight and practice them for the next few nights. It is in your best interest to have them down pat. I know you're going to have a cheat sheet with these 6 things written on it for the test, but trust me, you want to just have these things down cold.